So we're given that f of x is equal to 2x plus 3 all over negative x minus 3. And we're asked to show that f of x is equal to 3 all over x plus 3 minus 2 for 2 marks. Alright, so we're given 2x plus 3 all over negative x minus 3. And remember, our goal is to show that this is the same as that. So we're basically writing this function in the standard form of a hyperbolic function. Alright, so what we need to do or take into consideration is this 2x plus 3. We can change this plus 3 into plus 6 minus 3 all over negative x minus 3. The reason why we're doing this, we have to make the numerator the same as the denominator. Why am I saying that? This 6 minus 3, this minus 3 is present in the numerator and in the denominator. And 6 minus 3 is basically rewriting 3 in a different way. So 6 minus 3 is the same as 3. And we also change it to look the same as the denominator. Okay, and then from there, we should agree that 2x plus 6 all over negative x minus 3 minus 3 all over negative x minus 3. This is basically the same as that. It's just that we rewrote the form. So this is the same as that because they share the same denominator. Now let's simplify this side. So remember, we're trying to change this negative x minus 3 into x plus 3. So let's deal with this side first. So it's going to be 2x plus 6 all over. We have to factor out negative 1. Okay? And then when we factor out negative 1, it's going to be a positive x. And then negative 3 divided by negative 1 is going to be a positive 3. And then minus 3 all over. Factor out negative 1 again. Negative 1 into x plus 3. Okay, so we're getting closer to the answer. Now in the numerator between these two, there's actually a highest common factor of 2. So we're going to factor out 2, and then it's going to be into x, 2x divided by 2, that is x, and then 6 divided by 2, that is positive 3. Close the brackets, all over negative 1 into x plus 3. And then this negative, when you take it over here, negative times negative is going to be positive 3 all over x plus 3. So we're getting close to the answer. This is the same as that. And then let's deal with this part. This x plus 3 is going to cancel this x plus 3 out. And then it's going to be 2 all over negative 1 plus 3 all over x plus 3. And then 2 divided by negative 1, that is negative 2 plus 3 all over x plus 3. Now this is the same as that, we just have to change the order. It's going to be 3 all over x plus 3 and then minus 2. So we have shown that this function can be rewritten like that. This is only 2 marks. I don't know why it's supposed to be 2 marks. I think it's supposed to be even like 3 or 4 marks because there's a bit of calculations over here that we have done. So let's determine the coordinates of the intercepts of f with axes for 3 marks. So we're given this equation, but remember we solved it to look like that. So it's a hyperbolic function. So looking for the x-intercept and y-intercept. So we have y is equal to 3 all over x plus 3 minus 2. Now let's look for the x-intercept first. And remember, from the x-intercept, y is always 0. Okay? So let's substitute 0. We're now looking for the x-coordinate. So 3 all over x plus 3 and then minus 2. So let's simply solve for x. Negative 2 across the equal sign is going to be positive 2 is equal to 3 over x plus 3. Now we can see that there's a denominator, so let's take this denominator and multiply it on both sides. So it's going to be 2 times x plus 3 is equal to 3 all over x plus 3 times x plus 3. So 2 times x plus 3, that is 2 times x, which is 2x, and 2 times 3 is positive 6, is equal to this x plus 3 will cancel this one out because this one is in the numerator, This one is in the denominator, so we're left with 3. And then it's going to be 2x is equal to 3 minus 6. Okay? And then 2x is equal to negative 3. Divide by 2 on both sides. X is equal to negative 3 over 2. So this is the coordinates of the x-intercept. So it's x-intercept. It is negative 3 over 2 and 0. Now let's solve for the y-intercept. Again, y is equal to 3 all over x plus 3 minus 2. Now in the y-intercept, x is always equal to 0, so y is equal to 3 all over 0, because x is always 0 in the y-intercept, plus 3, and then minus 2. Y is equal to 3 all over 0 plus 3, that is 3, and then minus 2. Y is equal to 3 over 3, that is 1, and then minus 2. Y is equal to 1 minus 2, that is negative 1. So we have found the y-intercept. So the coordinates for the y-intercept are negative 0 and negative 1. And then you are done. This question we forgot to answer the part which says with the axes. So the axes are the axes of symmetry because it's the hyperbolic function. So the hyperbolic function, the axis of symmetry, this part over here, so the standard form says a all over x plus p minus q. Y is equal to a over x plus p minus q. And the coordinates of the axes are negative p and q. Okay? And then from there we can see that there's a positive 3 over here and there's a negative here. So it's going to change the sign over here, so it's going to be negative 3 and this negative 2 will remain as it is, so minus 2. So these are the coordinates of the axes of symmetry. Or you can say x is equal to negative 3, y is equal to negative 2. Okay, so we're now asked to sketch the graph of f, clearly indicating the intercept with axes as well as asymptotes for 3 marks. Now so asked to sketch the graph of f and clearly indicates intercepts with axes as well as asymptotes for 3 marks. So this is just basic explanation of the diagrams. So when you have a positive hyperbolic function, it moves in the first quadrant and in the third quadrant. When it's negative, it's in the second and fourth quadrants. You can see this by the gradients. This is the gradient. It's positive 3. So our function is going to be something like this. Alright, so let's draw our Cartesian plane. It won't be steady because I'm not using a ruler. So remember from our previous question, we got our coordinates. The y-intercept was 0 and negative 1. Our x-intercept was negative 3 over 2 and 0. And then the coordinates for the asymptotes were negative 3 and negative 2. So to make things easier for us, let's just draw the asymptotes first. So we have our negative 3, it's indicated over here, should be somewhere here. So remember, this is the x-axis, this is the y-axis. And the negative x direction is in this part, and the negative y direction is in this part. Alright, so we have negative 3 over here, which should be our vertical asymptote. And then we have negative 2, which is in the y-axis. So that is our horizontal asymptote. Okay, and then from there, let's now draw or indicate first our intercepts. So we have the x-intercept as 0 and negative 1. So negative 1 should be somewhere here. And then we have negative 3 over 2 and 0, so it should be somewhere here. So this is negative 3 over 2 and 0. This is 0 and negative 1. So let's now join these two. You see our function is moving in this direction. Remember, it shouldn't touch the asymptotes, because the asymptotes is the line where the function never touches. And then we have our second part moving like that. And you can see that it actually corresponds with this one, because we have a positive gradient. And then we have sketched for 3 marks. Determine the equation of the axis of symmetry of f, which is a decreasing function for 2 marks. So a hyperbolic function in basic terms, what they're actually asking for. So let's say this is your hyperbolic function. And then you have your axis of symmetry. So you have a positive axis of symmetry, or you can have a negative axis of symmetry. And you can see that these are actually straight lines. And the equation of a straight line is y is equal to mx plus c. So when you have a positive increasing function, you have y is equal to x plus c in terms of hyperbolic function, and when it's a decreasing function, it's y is equal to negative x plus c. So where am I going with this? We have to use the coordinates of the asymptotes, which was negative 3 and negative 2. And we simply have to substitute it into this equation. And how do we do that? So we have y is equal to negative x plus c. So we're basically going to substitute this x coordinates and this y coordinates into this function and solve for c, so we can find the equation of the decreasing function of f, which is the axis of symmetry. So let's substitute these coordinates in the y, and substitute negative 2, is equal to negative 1 times negative 3 plus c. Negative 2 is equal to negative 1 times negative 3, that is positive 3, and then plus c. Negative 2 minus 3 is equal to c, and then negative 5 is equal to c. So it's y is equal to negative x minus 5. This is the equation of the axis of symmetry of f, which is a decreasing function. Determine the values of x for which f is decreasing for 2 marks. Okay, so remember our hyperbolic function when we sketched it, it was something like this. We had our vertical asymptotes and our horizontal asymptotes. This was negative 3, and then this is negative 2. There is something like this and like this. Okay, so we're looking for the values of x for which x is decreasing. Now we're looking at the function. I always like to say maths is a language. So when looking at the function, x is decreasing for all real numbers of x, or for all values of x. But remember, x cannot touch negative 3. So instead of saying for all real values of x in this function, except x cannot be negative 3, just write it in this term, in mathematical language. You just say x is an element of real numbers where x cannot be negative 3, because negative 3 is our asymptote. So this basically means for all values of x it is decreasing, but except x cannot be negative 3.